Let's take our rocket engine and let's flip it around. So now our rocket is pointing out the front of the car. And that way, we actually have the effect of that rocket pushing the car backwards like this, but assuming the same amount of flames are coming out, still with that 5 meters per second acceleration that it gives it. Only this time, the direction of the acceleration is negative. Get rid of the positive here. All right, so if the direction of the acceleration is negative, that says that now the speed of the car the next second will change by 5 meters per second again, but this time it will change in the negative direction. And so after the 4th second, instead of going 15, now the car is going back to 10 meters per second, but still traveling in a positive direction. Notice the acceleration doesn't say what direction the car is traveling. It merely says what direction is the car changing its velocity by. Not what is its velocity, but how much is it changing and in what direction. So its velocity is changing in the negative direction. And again, assuming we still have the engine pointing backwards, then after 5 seconds, the velocity will be 5 meters per second. And let's keep the engine pointing backwards for the rest of our example. Then this will be 0, and then it will be -5 and -10. Now, can you see from where in this information the car has switched directions of travel? If you said right here, that's not correct. Here, it's merely the acceleration that's changed directions. That is, the direction in which the velocity is changing. Is the velocity going up or going down? That's changed right there, but the car itself has not changed direction. In order to see that, we have to look at the sign on the velocity, because the velocity tells us what direction we're traveling. And so you can see right in here is where the car has changed direction. It's stopped, and then it's turned around and headed back the other way. Now, what happens right here? In that area right there, in this area right here, the car has gone from speeding up to slowing down. Once the acceleration switched, the car begins to slow down. Now that can contribute to another common misunderstanding, which is that negative acceleration means slowing down. And it does here. But let's take a look way down at the bottom here. Notice this. Here we were at 0 meters per second, and the acceleration -5 caused our velocity to change from 0 to -5. Now this is the speedometer reading. Your speedometer is going 0 to 5 to 10. So you are speeding up. You're going faster and faster, even though the acceleration is negative. It's just that now you're going faster and faster in the opposite direction. Here you're going faster and faster in the positive direction, here in the negative direction. So knowing the direction of the acceleration, positive or negative, doesn't really tell you whether you're speeding up or slowing down unless you also know what your velocity is. Combining the two together can tell you whether you're speeding up or slowing down or speeding up. Now I want to add a little bit of information to this. I want us to also consider the average velocity, at least in various time intervals. And so in the interval from 0 to 1 second, 0 to 1 second, what is the average velocity? Well, let's see, it started at 0 and ended at 5. So that means on average it was going 2.5. In the interval 1 to 2 seconds, it started at 5 and ended at 10. Half the time it was going slower than the average, half the time faster, so on average it was going 7.5 meters per second. In this interval, from the 2 to 3 second interval, it was going 12.5 on average. That is the average between those two, the beginning velocity of that interval